Disclaimer, I'm almost shaking. This is legitimately, I'm not even kidding, my eighth attempt trying to make this video. And I'm either going to laugh or cry. There's been technological issues. I stumbled over words. The internet craps out. I don't know what to tell you, but this is my eighth attempt. So if I don't get through this video successfully, we're just going to, you get what you get. Okay. So for topic two, for the eighth time, we're going to compare integers. So when you're in a math class of this nature, when you're talking about comparing numbers, we're talking about comparing the size of the number, which number is bigger, which number is smaller. Okay. So that's all we're really doing here. And in some cases, it's really easy. If you're comparing a positive and a negative number, piece of cake. If you're comparing two positive numbers, pretty straightforward. It's when you start throwing in two negative numbers that we have to be really, really careful. So I want to make sure you understand this really well now, because later we might need to compare like decimals or fractions, and that's where numbers get a little bit more complicated to work with. So let's really understand what's going on here so that when we apply it later, we're fine. Now, in order to compare numbers, whether they're integers or any other type of numbers, we need to use things called inequality symbols. Now, at this point, we're really only going to use two of them. The other two are much more applicable when you get to an algebra class, but I want to introduce all four of them, okay? So in this little image, we have greater than, followed by less than, then we have greater than or equal, and then we have finally less than or equal, okay? We're going to use the two inequality symbols that are called the strict inequality symbols. So just greater than or just less than. So you're strictly greater than or you're strictly less than, okay? The other two of the or equals, you'll see those when you get to an algebra class. Now, inequality statements have to be read from left to right. Okay, so you have to have a true statement from left to right. That's really important. Make sure you understand this right here. Okay, now to state something really simple like 2 is less than 5, we need to make sure we understand 2 comes first, 5 comes second, and then we have to put the appropriate symbol in between those two numbers so that the statement is true. So we would want to say quite literally 2 is less than, so you want to put the less than symbol and then 5. So you would write that statement like this: 2 less than symbol 5. Now that seems really easy, and it is. I mean, truthfully, it is that easy, but you do need to make sure you understand two things. When it comes to these inequality symbols, you have to know hard and fast which one is greater than, which one is less than. You can't stop and think about it. You just got to kind of know. So the way I learned this when I was younger was uppercase L, think uppercase L for less than. It's not too far a stretch to kind of envision squishing that L and making it the less than symbol. So when I look at the two inequality symbols, when I see that less than symbol, I see kind of a squished uppercase L. So I think L for less than. That's how I keep the two separated. Do what works for you. The second thing you have to understand is the point versus the open side of the inequality symbol. The open side of the inequality symbol is always going to be facing the larger number. The point is always going to be pointing towards the smaller number. And at some point in your math career, you have had a teacher, I'm sure, that has used either an alligator or like Miss Pac-Man as the example. Like Pac-Man's going to eat the bigger numbers and the alligator's going to eat the bigger numbers. So I will never go so far as to put teeth on my inequality symbol, but if that works for you, envision teeth on your inequality symbol as a little alligator mouth eating those bigger numbers. So again, the open side, the wide side goes towards the big number, the point goes towards the smaller number. So let's look at just a few really quick examples. Example 3 says insert less than or greater than between each pair of numbers to make a true statement. So part A, we have 5 and 3. We all know just from general day-to-day life that 5 is bigger than 3. If I have 5 candy bars and you have 3 candy bars, it's easy to see that I have more candy bars. If you have $5 and I have $3, it's easy to see that you have more dollars than I do. But let's understand how this is on a number line, because sometimes you might get stuck with an example that you don't quite see, and that number line might help you. So we're going to go ahead and just really quickly use a number line for each of these examples. Okay, so for part A, if we had a number line, I'm just going to kind of label the part of the number line that's really useful to us. So I'm going to indicate that 0 is right here, and then I've got 1, 2, 3, 4, 5. Now remember, in the previous video, I said when you're looking at a number line, numbers to the right are getting bigger, numbers to the left are getting smaller. So when you're to the right of 0, you're positive. When you're to the left of 0, you're negative. But even further, if you're anywhere to the right of a number, you're bigger. If you're anywhere to the left of a number, you're smaller. Okay, so in this case, 3 is to the left of 5, which tells me 3 is less than 5. We have numerical number line proof here that 3 really is less than 5. So for this statement to be read correctly, I would need to say 5, throw in a greater than symbol, 3. So we're going to input a greater than symbol to make this statement true. It has to read correctly from left to right, okay? And notice the open side is going towards the bigger number, which is 5. The point is going towards the smaller number, which is 3. All right, part B, we flipped it all around on us. We've included negatives with each of those numbers. And it's generally when you're comparing negatives that students struggle, okay? It's not that it's a hard thing, it's just harder than comparing positive numbers is all. So we're going to indicate some important pieces here. So I've got my 0, my -3, and my -5. And remember, if we're to the left of 0, we already know that we're negative. But the way numbers work just in general on a number line, any number to the left of something is going to be smaller than that something. Anything to the right of something is going to be bigger than that something. Since 5 is to the left of 3, that tells me that 5 is smaller. And that kind of makes sense. If we're dealing with negative balances in a checking account, -5 is a worse negative balance than -3. If we're talking about temperature, -5 is colder than -3. So we can see here with numerical number line proof that -5 is less than -3. So we want to throw in a less than symbol. Notice the point goes to the smaller number, the open side goes to the bigger number. Now, when you're comparing a positive and a negative, the negative is always smaller, period. Okay, well, let's go ahead and draw this on a number line just for the sake of practice. So I'm going to put my 0, my 3, my -5, and we can see very clearly -5 is to the left of 3. We know that -5 is less than 3. So I'm going to throw in a less than symbol. And finally, I don't want to get too cocky that this might be the one that really sticks. Maybe this 8th attempt is it. We're finally almost through this video. So we get 0, 1, 2, -3, 1, 2, 3, 4, +5. So from this number line, we can see here really clearly that -3 is to the left of -5, which makes it smaller. So for this statement to be read true, we have 5 is greater than -3. So there you have it. That is comparing integers. We got through it. Let's see how the next videos go.